Hi guys, so today is our last day on exponential functions. After this we're going to transition and look more at log functions. So what we're looking at today is just regression and modeling. And just looking at data sets and determining does exponential the best fit, or maybe it's a quadratic or a linear model. So what we're going to do is we're going to start just by looking at a table. And we're just going to determine what kind of data this is telling us. Well, the first thing we're going to check for is we're going to see, are our x values evenly spaced? If they're not, we're going to have to do a lot of extra work. But in this case, they are. So all we need to do then is consider what our y's are doing. So let's see how these y values are changing. So what you may notice, each time, they're doubling. I'm multiplying by 2. So if we're multiplying by a constant amount, then we say that that function has a common ratio. And that common ratio tells us that this is an exponential model. So this would be an exponential function. That would be the best use of if we want to try to graph this. All right, let's look at our second one. So if you look at what's happening here, it's kind of hard to tell. So to get from the first to the second, I'm subtracting 2. Then I'm adding 2, and I'm adding 6, and I'm adding 10, adding 14, and I'm adding 18. That doesn't really give us anything that's very clear. But if you look at what's happening to that change, to go from -2 to +2, I'm adding 4. To go from 2 to 6, I'm adding 4. So the way that that's changing is consistent. Well, what we call that is we call that the second difference. And if those second differences are constant, then that shows us that this is a quadratic model. And that data is best modeled with a quadratic function. All right, then let's look at this last one. We're subtracting 3, and subtracting 3. Well, this one's pretty easy to tell. You have a constant slope. This is a linear function. All right, let's go ahead and look at the last one. Again, this time we're dividing everything by 3. Well, another way to say dividing by 3 is multiplying by 1/3. So this is also an exponential model. All right, so what we're going to do now, we're just going to go ahead and review what we did last class. We're going to write the equation in the form of a times b to the x that goes through those points. And we said probably the easiest way to set this up was with a system. So I could do 6 equals a times b to the first, and 54 equals a times b to the third. Well, if I solve this, or solve for a, I would get that a is 6 over b. Plug it in. So 54 is equal to 6b squared. 9 is equal to b squared, and b is equal to 3. Remember, b is not going to equal -3 because a negative base is really not going to be an exponential function. Once we know what b is, we plug it back in, and I get that a is 2. So my equation would just be 2 times 3 to the x. All right, we'll go ahead and try the same thing on the next one. All right, so I would do 2 equations. 10 equals a times b to the first. 40 equals a times b to the third. So solve for a in that first equation. Substitute it into the bottom equation. So 40 is equal to 10b squared. And I get that b is 2. Plug it in, and I find that a is 5. So algebraically, we can find these. Now, what we want to know though is what happens if there's not nice. We've gotten really nice, pretty easy values whenever we've done these. But if we get some pretty ugly decimals, there may be actually another method that we can use to find that function, and that method's going to be regression. So what we're going to do is we're going to use regression on our calculator. So we can use that for as little as those 2 points. If you want to go ahead and test it, you'll see you get the same equation. We also can use it for a set of data that isn't going to be exactly the same, but could give us a pretty good model. So the steps for regression, we did this back with quadratics. You probably did it with linear functions as well, in Algebra 1. But what we're going to do, this first one, it tells you the store sells trampolines. The table shows the number of trampolines sold during whatever the year was. So we're going to write an exponential function that models that data. So in order to do that, we're going to go to our calculator. We're going to go to statistics. We're going to type our x's into list 1, and our y's into list 2. And I went ahead and already plugged those values in. Well, this one does tell me to find exponential. But if I don't know that kind of model, one good option is to go to your graph. So the first thing I would do is press F1, and I'm going to do graph, and then I'm going to do F1 again, and do graph 1. Well, that kind of helps me to see what this model kind of looks like. So I can tell it's not really a straight line. It could maybe be a quadratic. It also could maybe be exponential. All right, so from that point, we could go ahead and try and find what our equation is. But now let's just go ahead. This one tells me to do regression. So I'm going to go ahead and do regression. So I'm going to do F2 for calc. I'm going to do F3 for regression. And then this shows you a lot of different regression models. Okay, I've got x squared, x to the third. I don't see exponential though. So I'm going to go ahead and do F6. And then I see more options. Now I see exponential. And now it gives me two options. I can either have this in the form of a times b to the x, or I also could have a base of e and find my rate that way. Now we're going to go ahead and do a times b to the x because that's the model we've been working with most often. And then we just use those coefficients to find our model. So this model exponentially would be y equals 8.46 times 1.42 to the x. And then we can use that model now to try to predict different things. But what we need to consider is even though we found a model that fit this data pretty well, and again, how we can tell is you can look at that r squared value. It's pretty close to 1. So that model is pretty close to that data. Well, we need to think about if that makes sense for this problem. Okay, we've got a store that's selling trampolines. And they still, after 7 years, have not sold more than 100 trampolines. Well, let's go ahead and plug in 15 to that equation. And let's see what we get. So if I plug in 15 to that equation, then I'm going to get 1,628 trampolines. So this company, in just the same number of years that it took to get to almost 100, we're now saying is going to be able to sell over 1,500 trampolines in 1 year, which would be a crazy large profit. Now, while this can happen with some companies, it doesn't really seem to be the most reasonable. So we may need to consider another model that just makes more sense for this particular problem. So really what we need to consider is not just the data points, but also what those data points actually mean, and if exponential makes sense. All right, so guys, this is really a short video because, again, this is just some calculator application stuff. We are going to actually do an activity in class to spend a little bit more time kind of working on this regression and seeing exponential growth and decay. But other than that, that is really it before your quiz.